Hey guys, here's the review for Spiral 15. We're going to start off by looking at some graphs of graphs of exponential equations, which are going to take the form y is equal to a b to the x plus k. First up, I'm going to take a look at number 1, and I happen to notice that my horizontal asymptote is at -2. That means my k value is -2, so my equation is going to start as y equals ab to the x, and then -2. I don't see what value that is at 0, so this is going to be kind of a mess of a problem, which I'm not thrilled about, but that's okay. I've got the point 2 comma -3 to work with, and then it looks to me like I've also got the point 3 comma -4 to work with, so I'll do the best I can. Okay, let's plug that first point in first, so -3 is equal to a b to the 2 minus 2. I'm going to add 1 to both sides. -1 is equal to ab squared. I'm going to divide by b squared and end up with a is equal to -1 over b squared. I'm going to use that in my other equation for this. Okay, looking at my next piece, so then we're looking at my other point. -4 is equal to a b cubed minus 2. So -2 is equal to a b to the third. I got that a is equal to -1 over b squared in my previous problem. I'm going to plug that in here. So -2 is equal to -1 over b squared times b cubed. That's going to cancel out, leave me with just -1b. So -2 is equal to -1b, or b equals 2. Okay, that's pretty cool, so I found that out. I can also use that in this equation, so that I can say that -1 over 2 squared is equal to a, which means that a equals -1/4. That actually pretty quickly solved my equation for me. We'll put that down here. So y is equal to -1/4 times 2 to the x minus 2. All right, looking at our other one of these. In this case, I've got a horizontal asymptote at -1. So y is equal to ab to the x minus 1. Look for a couple points. It looks like I've got a point at 1 comma -3, and it looks like I've got a point at 0 comma -5. Let's go for this one first. So -5 is equal to a b to the 0 minus 1. b to the 0 is 1. I'm going to add 1 to both sides, and I get -4 is equal to a. Let's plug that in. So y is equal to -4 b to the x minus 1. I'm going to use my other point, 1, -3. -3 is equal to -4 b to the -1 minus 1. I'm going to add 1 to both sides. We get -2. It's equal to -4 b to the -1. Divide both sides by -4. And I get a half is equal to b to the -1, which means that b is equal to 2. My equation, therefore, would be y is equal to, we said a was -4, b is 2 to the x, and then we've got -1 as my asymptote. I've also got to graph a couple of these guys. I don't really know why writing the equations came first today, but that's okay. So graphing these guys, I'm probably going to make a table. I'm going to take a look at my asymptote of +1. That's up here. I'm going to mark that y equals 1. And choose a couple points. Maybe start at x equals 2. Because when I plug that in, I get 0, so that's 1. -4 times 1 is -4, plus 1 is -3. So we got 2 comma -3. Maybe move up 1 value from here. That sounds pretty good to me. So 3 we're going to have 2 to the 1 is going to be 2. Negative 4 times 2 is going to be negative 8, plus 1 is negative 7. Maybe move back 1 to get it closer to my asymptote. So if I got, let's do positive 1. 2 to the negative 1 is going to be a half. 4 times a half is going to be 2. And negative 2, because we're looking at negative 4. So negative 2 plus 1 is going to be negative 1. All right, that's here. If I plug in 0, we get negative 4 times a fourth, which is negative 1 plus 1 is 0. That's cool, 0, 0. So I plugged in a bunch of points, and I draw my graph looking something like this. The same thing would be true for number 4. For the second part, we're trying to write things in terms of the same base in order to solve some equations. 6 and 216 can both be written in terms of 6, so 6 to the 2x, or k, I guess. 6 to the third is 216. That means that 2k is equal to 3, or k is 3 halves. Similarly, for number 6, we got 6 to the 3v and 6 to the negative 2v minus 2. That one's already set up for me, so 3v is equal to negative 2v minus 2. That means I get 5v is equal to negative 2. V is negative 2/5. Moving on, we're going to look at one more of these problems. Here I've got 36 to the 2x is equal to 216 to the 2 minus 2x is equal to 1. So the first equal should have been multiply. All of these things can be written in terms of a base of 6. So we got 6 squared to the 2x times 6 to the third to the 2 minus 2x, and then we're going to have 6 to the 0. So we've got 4x. We're going to have plus 3 times 2 is 6. 3 times minus 2x is minus 6x is equal to 0, because that's 6 to the 0. Combine some like terms. Negative 2x plus 6 is equal to 0. That means that 2x is equal to 6, and x is equal to 3. Next up, we're looking at some log basics. I'm going to go down the left side of this page. Okay, so for log base 2 of 1/16, we're looking for 2 to some power is equal to 1 over 16. I know that 2 to the 4 is 16, so 2 to the negative 4 is 1 over 16. The answer here is negative 4. You've got to show all this type of reasoning, because this could be done on a calculator and you will get points off if I don't see these steps. For number 11, we're looking at 7 to some power is going to be 49. 7 squared is 49. That answer is 2. For number 13, we just got to rewrite this in exponential form. We know that log base b of a is some exponent, therefore b to the e equals the answer to an exponential problem. So we've got 5 to the 3 is 125, and we are done. Here we've got to rewrite this in logarithmic form. Same thing but backwards. This one is going to be log base p, because that's my base, of 25 is equal to 3. If you want to do 16 as well, log base x of 143 is equal to y. Number 17, not really sure why these all got scrinched at the bottom. If I'm dividing, I'm really going to be subtracting, so this is going to be expanded to log of a minus log of b. I might do number 18 as 3 log base, it's common log, so 10 of x. I'm just bringing the power down. For 19, I'm going to start by looking at the division part for expanding. So we're looking at log base 5 of a squared minus log base 5 of b to the 4th. I'm going to bring those powers down to log base 5 of a minus 4 log base 5 of b. Similarly, for 20, we're going to look at splitting these guys up first. So log base 3 of x plus log base 3 of y plus log base 3 of z to the 6. Only one of these has a power. So to fully expand this, we can rewrite the first part's log base 3 of x plus log base 3 of y. Bring that power down, plus 6 log base 3 of z. For 20 through 24, we got to do some condensing. For 21, if we're subtracting two logs, that means we're going to divide on the inside. So x over y, positives on top, negatives on the bottom. 23, I'm going to take that and make that a power. So we've got log base 5 of z to the third. Divide by 2 is the same thing as a half. And hopefully we recognize that that can be put as an exponent. So we got plus log base 5 of x to the 1/2. Okay? Finally, we're going to combine the two things being added to get log base 5, z to the third, x to the 1/2, or log base 5, z to the third, square root of x. 22, I'm going to rewrite this as 1/2 log of a, which I could rewrite as log of a to the 1/2, or log of the square root of a. 24, I'm going to begin in a similar fashion. I'm going to convert these two guys to write this as log base 5 of c. That could be a half exponent or a square root. I'll do a square root. Log base 5 of the square root of a plus log base 5 of the square root of b. Okay, I'm going to combine these guys further. If I'm adding, I'm going to multiply. So we get log base 5 of c times the square root of a times the square root of b. You could leave it like this. You could rewrite this by combining the square roots as log base 5 of c times the square root of ab, and that would be okay as well. At this point, you are done.